Welcome to this short course on how to build a chatbot using Langchain. So, in order to understand Langchain, we need to understand what is large language models initially. So, let us dive into this and understand what are large language models. So, large language models are smart helpers that assist tasks with writing, coding, and customer service and more. The ChatGPT helps write mails, Gemini answers tough questions, and GitHub Copilot suggests code. They also let users interact with data, making it easy to analyze trends, summarize reports, and spot fraud using the simple language. Though they are powerful, they can still make mistakes but are constantly getting better. Now let's understand how LLMs work. So LLMs learn by reading massive amounts of text using the transformer-based AI understanding words in context. So when you type, they break it into tokens and predict the next word based on the patterns. So fine-tuned for tasks like GitHub Copilot or healthcare AI, they improve with human feedback, quickly generating responses like predicting shining for the sun is. Isolated LLMs can't learn in real time. They rely on past training data. So if last trained in 2023, they won't know 2024 events unless updated. So unlike humans, they can't browse the web or watch the news, limiting their ability to stay current. Finally, let's understand what is a Langchain. So Langchain is a tool that helps developers build smart applications using large language models, that is LLMs, like ChatGPT or Google's Gemini. It allows AI to connect with the real-world data, making it more useful and interactive. So it consists of several modular data and end-to-end templates. So the modular components in Langchain includes prompts that helps AI understand what to do by using the structured questions or instructions. For example, a prompt asking AI to summarize a document. The second one is models, the brains of the Langchain, including AI models like ChatGPT, Google Gemini, and others. Moving on, we have indexes, a smart storage system that helps AI quickly find the right information from documents, databases, or APIs. Now moving on to the next, we have chains, which connects multiple steps to complete a task. For example, fetching a document, then summarizing it, and then translating the summary. Now moving on, we have agents that act like a decision maker, choosing the right tools or actions based on the user request. So these parts work together to make AI smarter, faster, and more useful in the real-world application. So moving forward in this course, we will see how to use a Langchain document loaders to load data from a variety of existing sources. We will then touch on how to split these documents into semantically meaningful chunks. Next, we will give an overview of the semantic search, a basic method for fetching relevant information from a given user information. This is the easiest method to start with, but there are several cases where it fails. We will understand these cases and we'll see how to fix them. We will then see how to use those retrieved documents to enable an LLM to answer questions about a document. Finally, we will cover the memory and show how to build a fully functional chatbot experience through which we can chat with our data. In the next lesson, we will know about document loading. So, in order to create an application where you can chat with your data, you first have to load your data into the format where it can be worked with. That's when Langchain document loaders come into play. We have over 80 different types of document loaders, and in this session, we will cover a few to get comfortable with the concept in general. So let's jump in. First, we need to understand about loaders. So loaders deal with the specifics of accessing and converting data from a variety of different formats and sources into a standardized format. There can be various places we can load our data from, like websites, databases, and YouTube, etc. And in these documents become converted into data types like PDFs, HTML, JSON, Word, and PowerPoint. And so the purpose of different data loaders is to take this variety of data sources and load them into a standard document object which consists of content and then associated metadata. So now moving on to the types of documents. There are various types of document loaders in Langchain. It's not possible to cover them all, but here we have a rough. The first type is public unstructured. So here data that is freely available to everyone but does not have a fixed format. For example, social media posts, blog articles, YouTube videos. Anyone can access it, but it's messy and needs processing to be useful. The second one is public structured, freely available data that is organized in a clear format. For example, government census data, stock market data, weather reports in the databases. It's easy to analyze since it follows a structured format like tables. So the third one is a proprietary unstructured, the private data owned by companies but it's organized. For example, customer service emails, internal company reports, recorded phone calls, etc. So valuable insights can be found, but it requires effort to structure. Now the fourth one is proprietary structured. So the private well-organized data owned by companies are this type of data. So a bank's customer transaction records, Netflix user watch history, Amazon sales database, and more. So highly valuable, easy to analyze, and crucial for business decisions. So now let's jump into the fun part. So now we will understand everything in practical. So down the line when we do the coding part of building a chatbot, we will be using APIs and that API will be from OpenAI. So let's have a quick overview and the pricing details of an OpenAI API. So these are the reasoning models for complex and multi-step problems. OpenAI 01 and 03 mini. You have this $15 and $1.10. These are the GPT models for everyday tasks, GPT-4 Not and GPT-40 mini. Then we have the fine-tuning our models. This is customize our models to get even higher performance for your specific use cases. And this is basically for your training your AI. And now you can even go for exploring detailed pricing and also for fine-tuning and legacy models, real-time API. So this will give you an overview. So for building a chatbot using Langchain, the best OpenAI models are GPT-4 Not and GPT-4 Not mini. So it is the fastest and smartest model, great for the real-time conversations. And for a basic chatbot, GPT-4o mini is enough. For a smart and a fast chatbot, GPT-4 Not O is the best. So for an AI assistant with deep reasoning, 01 is the way to go. Down the line, we have also used the priced API and we have also buy the plan, and so you can go ahead and get it done. So initially we are going to import some environment variables that we need, like the OpenAPI key. So we will run this and then we'll first type of documents we are going to use are the PDFs. So let's download the relevant document loader from the Langchain. So here we are importing the PDF loader from the Langchain document. And then we are using this machine learning lecture 1 that a PDF format, and we are loading the pages by calling loader.load. And let's run this. Now we are planning to take a look at what we have loaded. So in this way we have seeing the length of the pages, and I will run this. So it is 22. So in this case we have 22 different pages in that PDF. Each one is a unique one. So let's look at the first one. So I will run this. And then we are planning C. So this is a page document, so can be a bit long. So let's print the first few hundred characters from this first page. So we'll run this. So this is a few hundred characters from that particular page. So the other piece of information is the metadata associated with each document and can be accessed with the metadata element. So we'll see that. So we'll see to find out the metadata, that is page.metadata, and we'll run this. And here you can see till that PDF one, is a source basically. So this is the name of the file we have loaded it from. The other is the page field and it corresponds to the page of the PDF. So the next type of document we are going to look at is the YouTube content. So I repeat, there's a lot of fun content in YouTube. So a lot of people use document loader to ask questions about the particular content, lectures or anything like that. So we'll see. So here we are basically going to see importing certain things here. The key parts are YouTube audio loader, which loads an audio file from a YouTube video. The other key part is an OpenAI Whisper Parser. This will use OpenAI's Whisper model, a speech-to-text model basically, that converts the YouTube audio to text format that we can work with. So we'll run this. So after the output, we can now specify the URL. Specify a directory in which we save the audio files. Then we can create a generic loader as a combination of this YouTube audio loader combined with that OpenAI Whisper Parser. And then we can load the documents by calling the loader.load corresponding to YouTube. So this makes a few minutes to load. So after this, we'll see how we can view the documents. So we will now write docs. We'll see the first content dot page content. We'll see the first 100 ones and we'll run and see. You can even see the first 100 words. We can actually take a look on the page content now, and this is the first page of the transcript from the YouTube video. So the next set of documents we are going to go is how to load URLs from the internet. So there is a bunch of educational content on the internet and it can be very cool to actually just chat with it. So we are going to enable that by importing the web-based loader from Langchain. So from Langchain.document loaders import the web-based loader. So I have given a GitHub link over here. You can choose any URL basically. So this is a markdown file from GitHub page and create a folder. So I will run this. Now basically we can write docs equal to basically calling the loader.load and we can run it. Now we are printing the first page of that, looking at the content. So I'll write print docs, obviously the first page, obviously dot page content, and I will write 0 to 500. And now I'll run this. Then we can just take a look at the content. You will find a lot of blank space. Okay, don't get confused, it's a part of it. And then you will find some content over here, and then again some blank space, and then skip to content, and then again blank space, and again all this. So this is basically interesting. So now we will finally cover how we can load data from Notion. So we have to perform certain steps. For example, a Notion site, you have to go to the Notion site, then duplicate the page into your own Notion space and export as a markdown or a CSV file. Then you have to come back and unzip it and save it as a folder that contains the markdown file for the particular Notion page. So after we have got the specific format, we can use the Notion directory loader to load the data and get documents that we can work with. And here we are importing the Notion directory loader, then we are using this Notion's doc, and then we are calling the loader. And now let's run this. Now let's take a look at the content. So I'll write print docs, obviously the first content dot page content, and I want to see the first 200 words. We'll use run. And we can clearly see it is a markdown handbook, that is Blender's employee handbook. And I'm aware that a lot of people has worked with Notion and has a Notion's database. So it's a great opportunity to export that data and bring it here and start working with this. Now in the next lesson, we will see how to split the documents. So we just now went over on how to load documents into a structured format. Now we are going to talk about how to split them up in a standard format. May sound easy, but there are various lot of subtleties over here. So document splitting happens after you have loaded your data into the document format. But before it goes to the vector store, and this may appear really simple, you can basically skip the chunks according to the lengths of each character or something like that. So as an example, why this is trickier and important down the line, let's take an example. The Honda Accord boosts an impressive 192 HP engine paired with a seamless 10-speed automatic transmission, delivering a smooth yet powerful ride that will leave a lasting impression. This is basically an example, and we are dividing it into two chunks. The first chunk is the Honda Boost and the second chunk is the other part of the text. And we are trying to answer one question, that is, what are the specifications of Honda? But here is the tricky part. None of the chunk alone can answer the question. So how you split one information, that is very important to get relevant chunks of information. So moving on, coming to the basis of all the text splitters in Langchain involves splitting chunk in some chunk size with some chunk overlap also. There are various types of splitters in Langchain. The first one is character text splitter. It split the text based on a specific character. For example, /n with the chunk size and overlap. The second is Markdown header text splitter. It splits Markdown documents while preserving headers and structure. Then comes the third, token text splitter. It splits a text based on the token count, ensuring compatibility with LLMs like GPT. And the fourth one is sentence transformer token text splitter. It uses sentence transformers to split text intelligently based on the semantic meaning. Now moving on to the next, we have recursive character text splitter. It splits the text hierarchically, first by large units, that is paragraphs, and then by the smaller ones like the sentences or words. Now moving on to the next, we have language. It's used for language-aware text splitting based on the linguistic rules. Second one comes as NLTKT XSplitter. It utilizes the NLTK to split text into meaningful sentence-based chunks. Then comes the Spacey text splitter. It uses Spacey's NLP models to split text while preserving grammatical structures. Now let's see how to split the documents for real. So we are importing OS, OpenAI, system, and even appending the path of system, and then we are even importing the load.env file, and then you can even read here what is that local.env file, and these are the very basic requirements, and we are gonna run this. So we will now import the recursive character text splitter and the character text splitter from langchain.textsplitter. So these are the basic two types of text splitters, and we are importing them. Let's run this. Then we will mention the chunk size, the desired chunk size equal to 26, and I'll write chunk overlap, I'll also mention this overlap, equal to 4, and let's run this. So after mentioning the chunk size and the chunk overlap, we are initializing the R splitter as the recursive character text splitter and the C splitter as the character text splitter, and we are even initializing the chunk size and the chunk overlap for each one. So let's run this. So we have this example of this text one, and let's see how it gets splitted. So I'll run this and I will write as, let's use recursive one, as I have already initialized it as recursive splitter. And let's run this. So let's use this text2 as an example, and then I'll submit this and again use our splitter dot split the text, and the text is use the text too, and let's run this. So now you can basically see it has got splitted into two parts. Now we have a different example, that is we are having each letters separated with a space. So now I will run this and I'll use both our splitter dot split text, and we are using text 3. I'll run this, and you can see it has even kept the spaces and it has divided into 3. I'll use C splitter now in the same example, dot split text, and it would be text 3. So let's run this, and now see it has even given up the same thing it was previously. So we are now again initializing the C splitter as a character text splitter and giving the chunk size, chunk overlap, and separator as we are even given the separator as space. So let's run this. So see, it has even uses the spaces to differentiate. So it's a great time to pause the video and try your own examples. In the next, we'll see the recursive splitter details, and it is basically used for generate tests. So we basically have this text over here as an example, and let's run this. Now let's see the length of this. How to see the length and then some text. It's 496 words. So we will now import from Langchain dot text splitter import character text splitter comma recursive character text splitter. So basically we are importing these two text splitters, the character and the recursive, from Langchain.TextSplitter. So let's run this. So now we are basically again initializing the C splitter as a character text splitter, and we are keeping the chunk size, the chunk overlap as 0, and then separator to be the spaces. And in the recursive character text splitter, this #n means the new line. So it is a double new line, a single new line, a separator, and even having a null one. So let's run this. So here I'll use the C splitter dot split text, and we'll go for some text. So I'll run this. So here the character text splitter splits it by spaces. Then I'll go for R splitter dot split text, and we'll go for some text again. We'll run this, and if you see here, it's a better split though, splitting into 2 paragraphs. So let's reduce the chunk size a bit and add a period to our separators. So here is a better option. We have given a double line, a single line, and even added period separators over here, and we will run this, and now we can see that the period separators are in the good places. To fix this, we can now do something logically better. Let's try it with a real world example now and load a ML PDF that we once used in the document loading session. So we are basically importing the Py PDF loader, and we are using that machine learning lecture that we once used in the first section, and we are even calling it loader.load. So let's run this. So we are initializing the text splitter is equal to character text splitter, giving a separator, a chunk size and a chunk overlap as well. And we are even passing the length function over here that will split based on the length of the text. So we'll run this. Now we are going to use the document text splitter. For that, docs equal to text splitter dot split documents pages. Now let's run this. So basically I have missed the documents S and written a error over there. So let's run this now. So it's done. Now let's compare the length of the document and the pages. So I'll write length docs and I'll run. So it's 77. So then I'll see the length of the pages and I'll run. It's 22. Now let's import this Notion directory loader from the Langchain, and then loader is equal to Notion directory loader, and we are passing one Notion database and then I'm calling it. Let's run this. So we are now using this text splitter for this Notion database and we'll run this. So now we can compare the lengths of the splitted document and the original document. So let's see length Notion database and we'll run this. It's 52. Now we'll see the length of the docs. We'll run. It's 353. So now we can also split on the token count explicitly if we want. This can be very useful because large language models often have context windows designated in tokens. So let's see how it goes. So we are now importing the token text splitter from the Langchain. So let's run this. So we are now initializing the text splitter with the chunk size and the chunk overlap that is equal to 0, and we are keeping it as token text splitter. So let's run this. So basically we have got a fun sentence, and let's give this and I'll split this. Text splitter dot split text 1. So I'll run this. So see, it's basically splitting everything with a comma. So it got separated into different tokens and every one is of different kind if you see. So let's write text splitter equal to token text splitter chunk size equal to 10, comma chunk overlap is equal to 0. Then run this. And again I'll write docs equal to text splitter dot split documents and we'll pass the pages document. I will run this. So again I got the same error, and let's not worry about this. We'll copy and I'll paste here and add an S and I'll run this. And then we can basically see the first one. This is basically the first document. Now let's look at the metadata even. Pages. There's the first document dot metadata. And we'll run this. So chunking aims to keep the text with common text together. A text splitting often uses sentences or other delimiters to keep related text together, but many documents such as the markdown have structures or headers that can be explicitly used in splitting. So we can use the markdown header text splitter to preserve the header metadata in our chunks. So we'll see that here. So here we are importing the Notion directory loader from the Langchain and as well as the markdown header text splitter. So here basically I have a markdown document that is title, chapter, this is gym and section and all this. So I will provide this. So we can basically now have the headers to split on, that is the header 1, header 2 and 3 hashes and header 3. So we'll run this. So we can basically now initialize the markdown splitter with the markdown text splitter, and even we are initializing headers to split on. And let's run this. Now we are taking a look at the splits. And the header splits 0. First one. Let's look at even the second. The header the same way. 1. So let's try it with a real world example. So here we have loaded the Notion directory loader and the docs as well. So let's run this. So here we have initialized how to split them and initialized even the markdown also. So let's run this. Now let's initialize the header splits with the markdown splitter dot split text, and let's run this. And let's have a look on how it got splitted. Let's run this. So this is it. Moving down the line, we'll see Vectorstores and embedding. We have now got our document split up into small meaningful chunks, and it's time to put these chunks into an index where we can easily retrieve them when it's time to answer the questions about this corpus of data. So to do that, we are going to use our embeddings and Vectorstores. Let's see what they are. So vector stage comes after the text gets splitted and is ready to store in an easily accessible format. And embeddings, they take a piece of text and create a numerical representation of that particular text. Text with similar content will have the similar vectors in numeric space. Now you might be thinking what they actually mean. So to find the similar text, we can actually compare the vectors. Consider these 3 sentences. The first 2 sentences, if you see, a dog is playing in the park and the canine is running in the playground, have almost similar vector values, indicating that they have similar meanings. The third sentence, that is, the ocean waves are crashing on the store, has a different vector representation, showing that it is unrelated in meaning. So let's see all this in action. So to start with, we'll once again set the appropriate environment variables. These are the set of CS2 to 9 lectures of, you can see there are 2 lecture 1, 2 and 3. So this is lecture 1 is duplicated because of simulating dirty data. So we'll run this. So after the data is loaded, we can use the recursive character text splitter to split the data and to create chunks. Let's run. So let's split it. Splits equal to text splitter dot split documents. Docs. We'll pass the docs over here. We'll run this. And then let's see the length. Now we can see that we have created more than 200 chunks. So time to move on to the embeddings. Let's take our splits and embed them. We will use the OpenAI to create this embeddings. So we are importing OpenAI embeddings from the Langchain Embeddings OpenAI. And now, before trying with the real world examples, let's try out some other examples as well. So we have random 3 sentences over here, and you can look that the first 2 are very similar. Now we can create an embedding class for each sentence. We have 3 sentences and therefore we are creating 3 embeddings. So we can import NumPy to basically compare them. We will expect that the first 2 sentences will be very similar. So import NumPy as NP. We'll run this. Then we'll compare both with the dot product. np dot embedding 1 and the one we will be comparing it to, that is embedding 2. We will be using this dot product to compare them. The dot product in here multiplies the corresponding elements of the two vectors and adds them up, so giving a single number. So it helps measure the similarity basically between the embeddings. Higher value means more similarity and lower value means less similarity. So we'll compare the other ones, np dot and embedding 1, comma, embedding 3. We'll run this. Now you can see that the dot product of the first and the second sentence was quite higher. And comparing the first and the third, we can get a significantly lower value. So we'll compare, one is also left, comparing 2 and 3. So np dot embedding 1, comma, embedding 2, comma, embedding 3. So let's run this. And you can see it's almost the same. Now I will suggest you to pause the video and try out a few different examples and their dot products. So let's move on to the real world example. It's time to create embeddings for all the chunks of the PDFs and store them in a vector store. So the vector store we will use here is Chroma. So let's import that. I have imported this Chroma. So Langchain has integrations with lots of vector stores. We are using Chroma here because it's lightweight and in memory, which makes it very easy to get up and started with. So there are other vector stores that offer hosted solutions which can be useful when you are trying to persist large amounts of data or persist it in cloud storage somewhere. So let's run this and we'll write persist directory. And the name of the directory is, we have to write in quotes, docs, Chroma, and again a slash. So let's run this. So we are going to want to save this in the vector store so that we can use it for the future lessons. So let's create a variable called persist like this directory, which we'll use later on at docs slash comma. So here, let's also make sure nothing is already there in the database. So we'll run this. So here, let's create the vector store. We can call Chroma from the documents. Then passing on splees that we created earlier, passing through embeddings. Now this is the OpenAI embedding and finally passing through a directory. So now we will look at the collection count. We can see that this is the same as that of the split we previously did. So let's now start using it. Think of a question that we can ask. We know that this is a class lecture, so we can ask if there is any email address, we can ask for help regarding class or anything. So the question is there any email I can ask for help? So I'll better run this. So we are going to use the similarity search method over here, pass the question and even k is equal to 3, which specifies the number of documents that we want to return. Then we will see the length of the document and we'll run this. And it's 3 as we have specified. Now let's look at the content of the first document. It's in fact about an email address and it's obviously the email we can send queries to. So let's run this. If you send email to this account, it will actually let us back to the maximal quickly with answers. So it's basically an email address. So I'll write over here vector db dot persist and I'll run this. So After doing this, let's be sure to pursue the database for future use. This seems great, and basic similarity search will get you about 80% of the way. They are very easily. But there are some failure modes that can creep up. For example, I'll show. So let's try out a different question. That is, what did they say about MATLAB? So let's run this. So we will use the similarity search over here, and k is equal to 5. So I'll run this. So I'll look at the first document content over here, and I'll run this. Let's see the second document as well. So notice that we are getting duplicate chunks over here because of the duplicate machine learning lecture 1 PDF in the index. So semantic search fetches all the similar documents but does not enforce diversity. So docs 0 and docs 1, that is the first document and the second document, are identical. We can see a new failure mode over here. So I will basically try out a different question that is involving the third lecture, and let's run this. So here I'll use the similarity search over here again with the passing the question, and k is equal to 5. So I want to basically check the metadata, and I'll run this. So let's loop over the document and print the metadata. We can see a combination of results, some from lecture 3, 2 and 1. The reason it is failing is that the third lecture and the fact that we want the documents from the third lecture is a piece of structured information. But we are doing a semantic lookup based on the embeddings where it creates an embedding for the whole sentence, and it's probably a bit more focused on regression. So I'll write over here print docs for, this is a third document, page content. I'll run this. So if you look at the fifth document, the one that comes from the first lecture, it does refer to regression. So it is picking up on that, but not on the fact that it is supposed to be querying documents only related to the third document, because again it is a piece of structured information. So good time to pause and truly figuring out some more queries and try changing the value of k. So in this lecture, we have basically seen the basics of semantic search and also the failure modes. So let's move forward in the next part and try to address those failures and retrieval too. So in this lesson, we will dive deep into retrieval and a few more advanced methods for overcoming the edge cases. So let's understand what is retrieval in Langchain. So in Langchain, retrieval refers to fetching relevant documents or data from a knowledge base like a vector database or local files to answer user queries. It helps in searching, filtering, and retrieving information efficiently. So where retrieval is used? So it is used in the chatbots with memory. For example, it is used in retrieving past conversations. Then comes questions and answering system. For example, retrieving the FAQ answers. Then comes the third, that is AI-powered search engines. For example, the semantic search. Now moving on, we have the techniques we will be talking about are new to the market. So the first one we have is maximum marginal relevance. So MMR is a smart way to select diverse and relevant information from a large set of documents. Instead of just picking up the most similar results, it balances relevance and diversity, ensuring that the retrieved results are not too repetitive. So MMR is used in the retrieval augmented generation, that is RAG, to improve search results by selecting both relevant and diverse documents. So imagine searching for the best AI tools. So without MMR, you get 5 results about ChatGPT. That is too similar. But with MMR, you get results about ChatGPT, Gemini, Claude, Midjourney, Copilot, and better variety. Now moving on to the next, we have LLM Aided Retrieval. So LLM Aided Retrieval is a smart way to improve search results by using a large language model to define or guide the retrieval process. So instead of just fetching documents based on the keyword similarity, the LLM helps in a better query understanding, ranking, and selecting relevant information. For example, without LLM Aided Retrieval, a search for the AI in marketing may retrieve random AI articles. But with LLM Aided Retrieval, the LLM understands the intent and retrieves specific articles on AI tools for marketing. It is used to improve accuracy for refining search queries, reduces irrelevant results, and improves retrieval quality. It works well with RAG, that is a retrieval augmented generation. So now let's see all these techniques in action. So let's see all the techniques in action. So we will start with loading the environment variables as we always do, and then we'll run this. So let's then import Chroma from Langchain vectors. We will also import OpenAI embeddings, and we will also create this persist directory we have created before, the docs Chroma, and we will run this. So after looking at the collection counts, we will now create embeddings. Embeddings equal to OpenAI embedding, vector Chroma, and then pass this persist directory and embedding function. So we will run this. So now we'll try to print vector db dot collection dot count, and we'll run this. So after looking at the collection counts, we can see this is 209 documents that we loaded before. So let's now begin with maximum marginal relevance MMR. So we have all this text that got loaded and all are about mushrooms. So we'll create a small database equal to Chroma dot from text, and we'll pass text comma embeddings equal to embedding. So this is a type of a toy example, and we will run this. So I have a different question. Tell me about all the white mushrooms with the large fruiting bodies. So I'll run this, and we'll create plugin called this small db dot max marginal relevance search. We will pass the question, then k is equal to 2, comma fetch. Make sure you give the correct code, and we'll run this. So here, if you see, we have still k value as 2, but fetch k is equal to 3 to fetch all the 3 documents originally. So now let's go back to a question, a previous lesson where we asked about MATLAB. So the question is, what did they say about MATLAB? And we have the vector similarity search over here, and the k value is 3. So now we'll basically compare docs ss 0 dot page content and we will run this, and we will again basically I'll copy this and I will change 2 to 1. Now we can actually see that both are the same. Now we will use MMR to actually find out the difference. So let's write docs MMR first document dot page content and we will copy this, paste it here, and we'll make it as 1. Now, the second one is different. It's getting some diversity in the environment. Let's now move on to the next part. So, we have a different question again, and we'll try to run this. So, we are here again using the VectorDB similarity search, and if you see, it is the third lecture over here. So, we'll try to run this. Now, if you see this, that you will understand that it got retrieved, that is exactly like the initial. So now we are going to use self-query retriever. So I'm importing OpenAPI and self-query retriever and attribute info. Let's run this. So here again we are specifying the metadata attributes like the name, the description and the type, and if you see the difference, the page from the lecture and here in the description it is the lecture, the chunk is from should be one of the documents from this. So let's run this. We will now specify it more and use LLM as OpenAPI model, and we will give retriever as self-query retriever from LLM and VectorDB and everything, and we will also here verbose is equal to true. So we will run this. So here we are basically retrieving the relevant documents and passing the question, and it is okay, and we'll print the metadata. This can be ignored and you can actually find out the metadata. So there are some additional tricks over here for compression. That is another approach for improving the quality of the retrieved documents is compression. So information most relevant to a query may be buried in a document with a lot of irrelevant text as well. So passing that full document through your application can lead to more expensive LLM calls and poorer responses. So contextual compression is meant to fix this. So I'll import contextual compression retriever and we'll run this. Here we are passing this pretty print documents through the documents, and we are even giving all the specifications of the double new line, page content and everything, and we will run this. So here we will wrap our vectors store. So we'll run this. We can now create a compressor with the LLM chain extractor as well. So we'll run this. We can now create the contextual repression retriever and then the best retriever from the vector store. And now we are passing the question and we'll run this. Now we are passing the question. Seeing the output, you can find out that the documents are shorter than the normal one, and they have some repeated stuffs as well. So it's not worth nothing that VectorDB is not the only kind of tool to retrieve documents. The Langchain retriever abstraction includes other ways to retrieve documents such as TF, IDF or SVM. So let's see. We will now begin with loading the environment variables like we always do, and we will run this, and then we will see loading the PDF, and then we are using the recursive character text splitter to split the text, and we are specifying the chunk size, the chunk overlap, and finally splitting it. So after splitting is done, we will be using the retrievers SVM retriever and TF-IDF retriever, and we will run this. And then finally, we will ask this question, what are the major topics for this class? And we will basically run this. Now you can see the page content. Let me just check about what questions you have right now. So if there are no questions, I will just, it has given it. So now we are using the TF-IDF retriever and let's run this. So this is the right time to pause and try your own examples. Down the line in the next lecture, we will see how we can ask questions and get the relevant answers. In this lesson, we are going to cover how to answer the questions with the documents you have just retrieved. So this stage comes after the retrieving documents section, and the workflow is first the question comes in, and then we look up to the relevant documents, then pass through the splits and prompts as well, and then the human question for the language model, and finally get the answer. Now let's see this in action. So we will start with loading the environment variables as we always do. So this code is basically assigned to the OpenAPI LLM version filmed until it is deprecated. So currently in 2023, LLM responses can often vary, but the responses may be significantly different when you are using a different version of model. So I'll run this. So my version is GPT 3.5 Turbo. So now we have loaded the vector database. So we'll run this and we will going to check whether it is correct or not. So print vector db dot collection dot count and we will run this. So we have got it is 209 and it is absolutely correct. So here we will do a quick similarity check and even see the length of the documents. Now basically we are going to initialize the model we are going to use to answer the question. We are using the chat OpenAPI model GPT and we'll run this. Now we are we are importing retrieval QA from the Langchain chains. So we can create it by passing a language model and then a vector database. So I'll print this and then we will call it with a query to check if it is equal to the question we want to ask. And then we can look at the result. So let's explore a few little things that is interesting. So first we will look is on the prompts. So here I have imported the prompt template from the Langchain prompts and have given one template, the question and an answer. So the prompt basically takes the question and the documents and passes it to the language model. So here I'll basically run the chain and you can create a new retrieval QA chain. We will use the same language model and the same vector store to pass in a few new arguments. So here I have a question, is probability a class topic? And I will pass this question and I'll basically pass it with a query and a question and I'll find out the result. So yes, probability is a class topic as the instructor assumes familiarity with the basic probability and statistics. Thanks for asking. So we can now try on a new question and look at the result. So I'll type result and in between I'll write source documents. After this I'll mention the first one. So for a little bit of intuition, I want to know from where it is getting the data. So I have displayed this. So there are also various type of retrieval QA chains. So we will see this one by one. So in this technique, each document is sent to the LLM to find the original answer. And then those answers are composed into a final answer with a final call to the language model. So here I'll again pass this with this map reduce and I'll run this. And again result I'll run this. So let me run the previous question through the same change. So it's a proper time to use a Langchain and to see what's going on inside. So once we have set the environment variables, we can now run this map reduce chain and then we can switch to UI to see what's happening there. So now we are using the refine technique and see that this is comparatively a better answer. The great thing about chatbots is you can basically take follow-ups based on the previous question's task. So let's see how it performs there. So we have built a QA chain over here and let me ask a question. The same question of previous. Okay. So now this is a follow-up question and I will try to run this. The prerequisites of the class are needed because the course assumes that all students have a basic knowledge of computer science and computer skills. So it is understood from the answer that the chain we are using doesn't remember anything of the previous question. So in the next lesson, we will introduce memory to fix this issue and make it fully functional chatbot. In this lesson, we will be making a fully conversational chatbot and with memory as well. So in the previous lesson, we were close to achieving the goal, but we can't handle the follow-up questions. That we will fix in this lesson. But before beginning, let's understand what do you mean by a chatbot. So a chatbot is a computer program designed to simulate a conversation with the users, typically through text or voice interactions. It can answer questions, provide information, or assist with a task based on your user input. So let's see how we can make the chatbot in real. So first, as always, we are going to load the environment variables. And then we are comparing the current date and the date time.date, and we are actually printing the version of the GPT. And now, if you have already have the platform set up, it will be nice if you can start in the beginning only. So let's specify your API key over here, and we have also done the Langchain tracing as to be true and the endpoint and my URL. Now we have loaded in the vector database and we have also imported Chroma and everything, and let's run this. So I have a new question over here and I am using this similarity search, and let's find out the length. So it's 3. We can run the basic similarity search on the Vectorstore like here. So we can now initialize the language model. We are using that. We are going to use this in our chatbot. So hello, how can I assist you today? So this is basically a language of a chatbot and we have acquired it. So let's do something more. And now we can even analyze, I repeat, and now we can even initialize a prompt and a QA chain and get the results back. So I'll run this. So we are adding memory to this. It will be working with the conversation buffer memory. So what is basically is it keeps a buffer of previous chats and the questions and will pass through while conversation. So here we will be using the conversational retrieval chain, and finally we are using this Langchain for the memory purpose, and I'll run this. We can even passing this LLM retriever and this memory over here like in this code. So I have a question over here and let's pass this question inside, and finally I'll demand an answer. And I will run this. So yes, probability is a class topic in the course. Fine. So I have basically a follow-up question and I'll try to run this and get the answer. So you can see that it can even have familiarity with the basic probability and statistics assumed as prerequisites for the course, because the course will involve concepts and applications that rely on probability theory and statistical analysis. So it's fine. So it's finally time to create a chatbot, a conversational chatbot. So we are importing the environment details over here and we will run this. And finally, we are giving the code. It's no worry, I'll explain it. We are finally loading the documents over here. We are using the py-pdf loader files and then splitting the documents using the recursive character text splitter, mentioning the chunk size and the chunk overlap. Then we are defining the embeddings, the open API embeddings, and finally we are creating the vector database from data. Then we are defining the retriever, and finally we are creating a chatbot chain over here. But keep in mind one thing, memory is managed externally over here. So we'll run this. So here finally I am defining the functions. I'm importing panel and param, CBFS, and finally giving all the codes, count and everything in it or no file specified. To make it, we are using even self-query, then we are using depends DB query, and finally with the response we are working on, then we are clearing the history and we are running this. And we are basically having it together will give you a nice UI. And let's run this. See, we have got a chatbot, chat with your data bot. So let's use this. We can now run this all together. We will be having a great UI, as you can see, a minimal one. So we can now ask who are the TAs. The TAs mentioned in the context are Paul Baumstrock, so it has given the names. So we'll ask a follow-up question over here about what are their measures. So the TAs and their measures they have given. We can go to the database and basically see the result of the database look, and we can give into chat history to see the questions asked. So this is the end of the class. In the final lesson, let's conclude this. So in this course, we explored the key steps in building a chatbot with Langchain, from understanding document loading, document splitting, then understanding about Vectorstores and Embeddings, then retrieval to implementing, question answering, and finally creating a fully functional chatbot. Through explanations and demos, we saw how Langchain simplifies the process of working with large language models, making chatbot development more intuitive and scalable. As AI continues to evolve, Langchain will play a crucial role in building smarter, more context-aware chatbots, integrating with real-time data sources and enabling seamless automation. The future of chatbot development is dynamic, and with tools like Langchain, the possibilities are endless. So guys, congratulations on completing the Building a Chatbot using Langchain course. You have taken a significant step towards mastering the AI-powered chatbot development. Now it's time to apply your knowledge, experiment with Langchain, refine your chatbot's capabilities, and explore new ways to enhance automation and user interactions. Keep innovating and make the most of what Langchain has to offer. Happy coding, and thank you for joining the journey.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.